Welcome to next lesson in relativity. In this class, we will discuss the verification of time dilation. Time dilation is one of the consequences of Lorentz transformation, which we have discussed in the last class. So, this time dilation effect is verified in different experiments. One of them is related to the lifetime of muons. Muons are elementary particles, and there are two types of muons, positive muons and negative muons. Both of them are unstable with an average lifetime of 2.2 into 10 raised to minus 6 seconds in the frame in which it is at rest. That is, this lifetime is called the proper lifetime of muons. It is the lifetime of muons measured with respect to their rest frame. And these muons are produced by the decay of pions. And these pions are also elementary particles. They are also unstable. So they will decay into producing muons. This conversion of pions into muons happens at the upper part of atmosphere, about 10 kilometers from the surface of Earth. So after their generation, the muon can travel a maximum distance is equal to speed into time. If we assume the muon is traveling with a velocity close to the speed of light, we can approximately take it as c into delta t0. So 3 into 10 raised to 8, which is the speed of light, into the proper lifetime of muon is 2.2 into 10 raised to minus 6. So we will get a 660 meter or 0.66 kilometer. So this is the maximum distance expected to be traveled by the muon. And the muons are created at about 10 kilometers from the surface of Earth. So after traveling a distance of about 0.66 kilometer, almost all the muons will be converted into electrons. Because muons are unstable, they will be converted into electrons. But practically a large number of muons are seen on the surface of Earth. So how is it possible that the muons produced at a distance of 10 km can reach the surface of Earth after passing a distance of 10 km, whereas the expected distance traveled by the muon is only 0.66 km? So the answer is time dilation. Because the proper lifetime of muon is 2.2 into 10 raised to minus 6 seconds, but the lifetime of muon in the laboratory frame is different, because muon is traveling with a huge speed. It is traveling with a speed of about 0.999 c. So the relativistic effect is very large. Therefore, the lifetime of muon in the lab frame is delta t equal to the lifetime in the proper frame delta t0 divided by root of 1 minus v square by c square. So putting the value, we get the lifetime of muon in the lab frame is 6.6 into 10 raised to minus 5 seconds. So with this lifetime, the distance traveled by the muon is distance is equal to speed into time, that is 0.999 c into 6.6 into 10 raised to minus 6. So we will get the answer as 20 kilometer. So in the laboratory frame, because of the time dilation, the muon can travel up to a distance of 20 kilometer. So it is very easy to reach the surface of Earth from the upper atmosphere where it is produced. So it can travel a distance of 10 kilometer very easily, and the presence of muons on the surface of Earth can be explained by using the time dilation. Another experiment is the time dilation of the lifetime of pions. As already said, pions are also subatomic particles. There are three types of pions: pi plus, pi 0 and pi minus. All of them are unstable. Out of these, the charged pions, pi plus and pi minus, will decay into muons, and their proper lifetime is 2.5 into 10 raised to minus 8 seconds. Proper means the lifetime in the rest frame of pions. And these pions are traveling in laboratory with about 0.9 times the speed of light. So in the laboratory frame, the expected lifetime of pion is delta t equal to delta t0 by root of 1 minus v square by c square. So we will get it about 5.7 into 10 raised to minus 8 seconds. So the average lifetime in the laboratory frame is almost double the lifetime in the proper frame. So relativistically, pions can travel at twice the distance in the lab frame than in their proper frame. That is called a proper, but then by using the proper time interval. So as the pions, velocity of pions is close to the speed of light, the expected lifetime of pion in the laboratory is much greater than the proper lifetime. All these facts are experimentally verified. So this verifies the time dilation. Also, the time dilation is experimentally verified by bringing sensitive clocks in aircrafts. When a clock is moving along with an aircraft and that moving clock is observed from Earth, we can see that the moving clocks runs slowly. Because the clock on the surface of the Earth, which is assumed to be at rest with respect to Earth, will be measuring the proper time interval, whereas the clock which is moving along with the aircraft is measuring the time interval which is not a proper time interval, and that time interval, the time interval measured by the moving clock, will be larger, it will be dilated. Time interval larger means that clock will be running slowly. So moving clocks run slow. It is another indication of time dilation. That fact is also experimentally verified. So the time dilation is experimentally verified by using different equipments. Thank you for watching this video.